about the potential difference, the resistance and the resistivity offered in an electrical circuit. Now let us see, in this problem you will be seeing that a wire of length L and area of cross section A has resistance 4 ohms. That means he has taken one wire, assume this is as a wire, and the length is L and the area of cross section is A. So we know the formula for resistance, that is resistance R equals to rho L by A. Now it is given resistance as 4 centimeters, that is 4 ohms, right? 4 ohms equals to rho L by A. Okay, this is the first equation. Okay, now the second point is, what would be the resistance of another wire of same material having the length L by 2 and the area of cross section is 2A. Then we will be substituting that L equals to L by A and area equals to 2A. Okay, now we will be seeing that R equals to rho L by A is the formula, we know that, and L equals to L by 2, that is rho into L by 2 by area equals to 2A, that is 2 into 2 equals to 4, that is 4A. Okay, now here we will be seeing that R equals to rho L by 4A. Okay, this is R1 for first conductor and this is R2 for second conductor. Now we have to find out what is the resistance of second wire. For R1 equals to, that is R1 equals to 4 ohms. Okay, now it is equals to rho L by A. We will be substituting this value rho L by A equals to 4 in second equation, that is R2 equals to rho L by 4A. In this we will be substituting, that means for this rho L by A equals to 4, we will be substituting this value, that is rho L by A equals to 4 in second equation. So we will be seeing that 4 by 4 equals to R2. Then we will be getting that is equals to 1 ohm as resistance. So the resistance offered by another wire is 1 ohm. I hope you understood it. I am showing it once again. See, R equals to rho L by A equals to 4 ohms for first conductor. Okay. Now for second conductor we got, that is R2 equals to rho L by 4A. Okay. Now this rho L by A value equals to 4. Here we got in first equation. That we will be substituting in the second equation and we will be getting 4 by 4, that is equal to 1 ohm as resistance offered by the second conductor. We have learned regarding the resistors previously. Now we will be seeing the types of resistors, that is series resistor and parallel resistor. These are based on the condition of their connection, that is we will be seeing here. See, in first figure we will be seeing that the resistors are connected in series. That means one end of a resistor is connected to the first end of the other resistor. You will be observing here, see, this is the first end and this is the second end, and this is the first end and this is the second of other resistor. This R1 first end is connected to the R2 second end. Therefore this type of connection is known as series connection, that is for last second end of the first resistor is connected to first end of the second resistor. This process of connection of resistors in series is known as series resistors. Now here we will be seeing that the amount of current flowing through these resistors is equals to I1, that is the amount of current flowing through R1 resistor, and at the same time the amount of current flowing through R2 resistor is I2, and whereas with the R3 it is I3. Now the amount of current, that is the total current which is passing through the circuit is I equals to I1 plus I2 plus I3. Now you can see the total voltage what is given to the electrical circuit with the help of a battery is V, that is Vt. Okay. And now let us see the parallel resistors. The connection is defined as when all the ends, that is all the front ends of the resistors are connected to one point, that is, for example, let us take, these are 3 resistors and the first ends of these 3 resistors are connected to one point, that is they are bunched up, they are tightly packed up and at one end, that is on the first end, that is all the first ends are tied up with one point and all the second ends are tied at second point, that is other end. And this type of connection is said to be as parallel connection, that is R1, R2, R3 are said to be parallel resistors. Now let us see the equations or the amount of current flowing through these parallel resistors, that is R1 is calculated as, see in this connection you will be observing that the current flowing through them is divided, that is it is divided into 3 parts, that is the amount of current flowing through this is I. Assume this is the total current which is flowing through the battery. Now the amount of current is splitted, that is I1, I2, I3. Okay. Now you will be seeing that I1 into R1 plus I2 into R2 plus I3 into R3. That is, we have studied previously, that is the Ohm's law, V equals to IR. Now in this we will be calculating the V total or voltage of the parallel resistor circuit equals to I1 into R1 plus I2 into R2 plus I3 into R3. Then we will be getting the total voltage in the parallel circuit. Now here we will be seeing that the voltage is divided across each resistor. That means here the amount of voltage is developed, that is V1, here it is V2 and here it is V3. See, you can observe that the current flowing through the resistors is same here because that is same current is flowing through here and it is passing through this whole circuit, right? Therefore, the current is not divided in the series resistors. That means I1, I2, I3 are equal. That is, it is said to be that they are divided equally. That is, if at all there are 3 resistors, then the current is divided by 3 parts. That means I1 by 3, 2I1 by 3 and 3I1 by 3. That means it is said to be as 3 parts. That is as shown in the figure. Here you are seeing the resistors, right? This is R1, R2 and R3. Now here we will be observing that the current flowing is same throughout the resistance, throughout the circuit. Therefore, I is same, that is equals to 3 parts of I total, that is equals to 3 is cancelled, that is I equals to I total. Here what I want to say is the amount of current flowing through the resistors in series circuit is same or it is constant. Now while coming to the voltage, it is divided regarding the series resistance because there will be a drop down voltage, right? And at the same time at each and every resistor there is drop down, and here you will be observing that it can be measured using the voltmeter. Right, now V1, I1, R1, V2, I2, R2. According to the Ohm's law equation, that is V equals to IR. V3 equals to I3, R3. But here I1 is equals to I2 equals to I3 equals to I, because same current is flowing, right? So the equation can be changed into V1 equals to IR1 plus V2 equals to IR2 and V3 equals to IR3. So here we can say that I is common and R1 plus R2 plus R3 gives us V total. Okay, I hope you understood, that is V total equals to I into R1 plus R2 plus R3. When the resistors are connected in series, we will be adding the resistance, that is R1 plus R2 plus R3. While coming to parallel resistors, we will be taking the LCM of these resistors, that is as shown in the figure. We will be solving the equation for the parallel resistors at the same time. See, we will be taking the equation of the parallel resistors, right? That is, current is divided in the parallel resistance case, whereas in series resistance case, voltage is divided. So, the current is divided into 3 parts, that is I1, I2 and I3. Okay, voltage is remaining constant because it is in a parallel circuit. The voltage flow is same in all the circuits, that is V1 is equals to V2 equals to V3 equals to V total, that is equals to V. Okay, now here we will be calculating the currents in the each resistors, that is I1 equals to VR1 and I2 equals to that is V equals to IR is the Ohm's law. Now we are taking I as the product, then I equals to V by R. Okay, this is the equation. Now V by R1, I1 equals to I2 equals to V by R2 and I3 equals to V by R3. Now here we will be taking V as common, right? That is V equals to 1 by R1 plus 1 by R2 plus 1 by R3. I hope you can see here we are taking the LCM of R1, R2, R3. But while coming to series resistance, we have taken the summation of the resistance. That is the difference. That is the major difference between the series resistors and parallel resistors. While coming to series resistors, we are giving the summation of the resistance. While coming to parallel resistors, we are taking the LCM of those resistors. Hope you get the difference. Now we will be differentiating with the help of a tabular column between the differences of parallel and series resistors.